Hello guys, welcome to the channel. In this particular video, we will be looking at the another coin change problem. So let's see what it says. Here is the problem statement and it says that given three integers n, k target and an array of coins of size n, find if it is possible to make change of target cents by using an infinite supply of each coin, but the total number of coins used must be exactly equal to k. Now you can see one thing, that this problem is very similar to the coin change problem. The only difference is we are allowed to use only k coins, right? Okay, now let's try to understand with this example. So for this example, we are given 5 coins, which are the value is given in this array, and the value of k is 3 and the target is 11. It simply means that we need to make change for 11 cents, and these are the coins that we have. So there are multiple possibilities. One of the possibility is we can choose 1 and then we can choose a 10, right? So this way I can have 11 cents. And the second way is we can do something like 6 and 5, or the third way is that we have 8 1 1 1. This is one of the ways, because we can use an infinite supply of each coin, right? The fourth way is we can use okay, we can have 1 1 1 1 1 and then we have 6, right? So this way there are multiple ways, and one of the way is that I can say is 1. After that we have, okay, so we have 5 and 5 again, and so there are multiple possibilities, right? And out of these possibilities, and we are allowed to consider only those possibilities which are using exactly k coins. So if it is possible, so I need to check out of these possibilities, right? And you can see that I have one of the possibilities where I'm using exactly 3 coins and I'm able to make the change for 11 cents, right? So this way the output is going to be true. So the output is as it is asking just if it is possible or not, so output is either true or false. For true we are using 1 and for false we are using 0, right? So now I hope you have understood the problem. So let's talk about the solution. Now here you can see that I have written the same example. The only difference is the value of k is 2 here, and here the value of k was 3, but I am using the value of k2 because this is going to help a lot. Now for this example, you can see that the first approach that will come to your mind is we can try out finding all the ways, right? And once we have all the ways, then we can simply check whether which of the way is utilizing exactly k coins, right? So let's try to do this. How to implement this? The task is pretty simple. That first of all, I have the value k and then I have target, right? So even let me write the value. The value of k is 2 and the value of target is 11. So what I can do is I can try to include all the coins. So if I include the coin 1, so this way you can see that since I have included this coin, so the number of coin, this says that the number of coins that I need to use, right? And initially I need to use 2 coins, but once I have used 1 coin, then I need to use 1 coin only, right? So this means that I'm reducing the value of k by 1. Now the value of target is also going to reduce and reduce by the value of this coin. So you can see that this is 1 cent coin, so the value will reduce by 1, and this way I will have 10 here. What about the second value? For the second value, this is a 10 cent coin. So for this, the value of target is going to be reduced by 10. So this way I will have 1 for this particular value, and for the third value I will have 1, and then I will have here, you can see that for this 5 I will have 11 minus 5, which is 6. For the fourth value I will have 8. I have 8 here, right? So I will reduce 11 by 8, so I will have 3 and then 1 here. And for the last value in the array, I have 1 and then 5, right? So these are the possibilities when I include 1 coin, right? And now for each possibilities, I can again include any of these coins. So for each possibility, I'm again going to explore all the possible ways to include the coin, right? So this is the way we can solve the problem. And when we complete this diagram, then this diagram looks something like this. And this is something which is a recursive tree. You can see that. Now let's try to understand this. You can see that for the first value, which is k and target, I'm exploring all the coins, right? I'm trying out for the solution for all the coins. But after this, for the first one, I'm including all the coins, and for the second one, for this I'm including only 1 coin. But why so? you can see that if I try to include this 10, since I need only one coin and I'm trying to include 10 coins, so this doesn't make any sense, right? So I will include a coin only if target is greater than equal to coins of I. This is very important. And again, if you ask me what I'm doing here, so I'm basically iterating over all the values, right? So this is like I'm iterating over all the values for I equals to 0 to n. This is what I'm doing. Fine. Now this is the first condition that I need to check, and when this condition is true, in that case I will solve for like further. I will solve further, right? Now again, you can see one more thing, that after this you can see that my k is 0 and my target is not 0 yet, so I will try to explore again. And when I try to explore, then the k of value then the value of k will reduce by 1, and then we will have -1 as the value of k. But we don't want the value of k to be smaller than 0. Why? Because we need to use exactly k coins, and the value smaller than 0 means we have used more than k coins, right? More than k. So this is something that we need to avoid. So we are going to check one more condition, that if k minus 1 is greater than equal to 0, only in that case we are going to check for these possibilities. And what we are going to check, we are simply going to check if it is possible. So if it is possible, then the answer will be in the boolean form, either true or false, right? And let's say for this answer is not possible, and for this answer is okay. So for this the answer is false, false, true, false, false. So what do you think should be the like final output if these are the values that are written by this particular thing? The final output should be true. Why true? Because we are just looking for the possibility, so we don't care whether it is false for this one. It should be true for at least one, right? So you can see that this is something like OR operation. So we are simply going to do one thing, that we are going to say answer will be equal to answer, or, and what is this? If we call this a function solve, then this is again the same function that we are calling. So it is like a function that we have solved, and we are calling this function for k minus 1 each time. You can see that we are reducing the value of k each time, and target minus coins of I, right? This is what we are doing, and at last we can simply return the answer. But let's say for this loop we are not going to iterate like over any values. In that case, like this condition is not true for any value, in that case the answer should be false, right? Answer should be false. So we need to initialize this answer somewhere. Okay, now I think I should move this thing to somewhere else. So I'm just going to cut it and I will paste over here. Now you can see that this is the code that we have, right? This is the code that we have. For this code, we can simply initialize the answer with false. Fine. So this is the way that we can try out all the possibilities, right? If we do this thing, then we are going to try out all the possibilities. But see one thing here, that this is a recursive call, right? So we have the same function here, and k and target. And for this function, we are going to call this function again and again recursively. But this function needs to stop somewhere. But at which point? So for this, from this you can notice one thing, that whenever our target becomes 0 and the coins also becomes 0, in that case I have my answer, right? So is there anywhere where my target is not 0 and my k is equal to 0? No, I don't think I have anywhere there. But let's say if I'm using let's say I have one coin 11 here, so in that way I will have my target 0 for the sixth iteration, but my k will not be equal to 0, so I need to avoid those ways. I'm only going to get my answer if my target is equal to 0 and at the same time my k is also equal to 0. Only in that case I can return true, right? This is the way that we can use to solve the problem. So this is basically the recursive solution, right? And the complexity of this solution is again going to be n factorial, something kind of n factorial, I'm not sure. But whenever we have a structure like this, we call recursion in loop, then the factorial then the complexity goes to this similar to this range, right? Fine. Now okay, again I'm not sure about this complexity, so you can find out what is the exact complexity of this code. But what I'm interested in is solving this problem with an optimal approach. So let's see what should be the optimal approach. Now you can notice one thing here, that as we are following the recursive approach, so for this approach we have something which is optimal substructure. Optimal substructure. But what is this? Optimal substructure basically means, optimal substructure means that the solution to every problem is dependent on the solution to subproblems. You can see that once we have found the solution for subproblems, then we can simply say that the solution for this problem is true on the basis of these subproblems, right? This is what we have noticed from recursive approach. We can notice one more thing from this approach. Have a look at this subproblem and this subproblem. These are same, right? And similarly, this subproblem and this subproblem is again same, and even this one and this one is also same, right? You can see that we have same subproblem again and again, we are going to solve them. So this is something that we need to avoid. So in that case, okay, you can see that for this we are not going to solve, but if we have a larger problem like k equals to 3 or 4, then we are going to explore these ways as well. So in that case we need to solve these subproblems as well. So we need to avoid this, right? So we have something which is overlapping subproblems. Now this is very important, guys, because at this point we get an idea that that dynamic programming can be applied here, because these are the two mandatory conditions for a dynamic programming problem. And you can see that the idea is pretty simple, that whenever we have repeating subproblems, then we just need to store these subproblems somewhere so that we can use them, right? So how we can store these subproblems somewhere? The idea is pretty simple. First of all, let me zoom this out. Okay, so this is the code that we have, right? For this code, first of all, I need a data structure which is going to store these subproblems, right? You can see that we have the value k, and at last the value of k will become 0, and it is not going to go beyond 0, like greater than 0 or smaller than okay, it is not going to go greater than k and smaller than 0. This is what I need to tell you. Similarly, for k, the value will be in range from 0 to target. This means that these are I will have k into target subproblems total, right? So we can make a data structure to store them, and you can see that since it is k into target, so we need to make a something kind of 2D array. So I will make a 2D array. Let's name it dp because it is a dynamic programming problem, and it makes more sense here to use dp. Now once I have written this name, so the size will be again k and target plus 1. Even k plus 1 should be there because we can have the value k as well, right? Fine. Now for this value, whenever we try to return our answer, we need to store this answer somewhere first. So first of all, we will do dp of k and target equal to answer, and after this we return answer, right? So this way, when we solve this problem, so this problem will be stored somewhere in the dp, right? And when we see the same sub problem again, so we will first check whether this problem is solved or not. How to check this? We will check if my okay, so we need to make this area more clearer, right? So I'll write answer equals to false here, and at this place I will check one condition. I will check if my dp of k and target is not equal to okay something kind of -1. Why I'm writing -1? Because I need to represent with some value that the problem is not solved yet, so I'm using -1 here. So I'll write -1. Even we can use null because null makes more sense here. So I'll write null. If this value is not equal to null, in that case I can return, because if this value is not equal to null means that the problem is solved already, right? So I'll return dp of k and target. This is what we can do. If you write this particular thing at this point, so our memoization approach is done. This is something which we call memoization in dynamic programming. So let's see the code in order to understand it better. You can see that I have the memoization code here, right? And I have written the code in Java, C++ and Python. So for the Java code, you can see here I have written the same recursive code, and then I have applied the memoization technique using a dp array. So this is how we can solve this problem in Java, and similarly this is the C++ code, and I have the Python code here. Now I hope you are clear with the memoization approach. So let's talk about one more thing, which is the tabulation approach. But why we need to talk about the tabulation approach? There's a reason. The reason is memoization approach is something which rely on the recursion approach, right? Which rely on recursive stack. Uh, Recursive stack. Why recursive stack? Because we are doing nothing but just modifying the recursive approach, right? And this is something which is again going to utilize the recursive stack, and we can avoid using this. We can avoid using this because this way we are using O of n cross target space complexity two times, first for stack and second for this DP array. So we can avoid this. What we can do is, as we know, we have k into target subproblems. These are the total subproblems that we have at most. So we can, what we can do is, we can iterate over all the values and try to fill the DP array. Once we have the DP array, we can try to fill it manually. For I equals to 0 and I smaller than k and I plus plus, what I'll do is I will do for j equals to 0 and j is smaller than target, even it should be equals to as well, and j plus plus. In this we will do one thing, that we are again going to iterate over all the array values. This is what we are doing. You can see that in the recursive approach we are iterating over all the values and we are doing this thing. We can do the same thing in the tabulation approach as well. We will do for I equals to 0. Okay, this is not I, this is actually for every coin for int. Okay, what I'll do is write for int coin in coins array, in coins array. So inside this I will check one condition. I will check the same condition even. I'll check this condition if target is if target is something which is greater than equal to coin, and my k minus 1 is greater than equal to 0 again, right? This is what I will check, and after this I can simply I can write one thing here, that dp of ij dp of ij is good. Dp of ij is basically the same sub problem that we have for k and target. Let me explain it. Dp of ij basically means, is it possible, is it possible to make the change for j target as j using exactly I coins? This is what dp of ij means, right? So we can write dp of ij equals to dp of ij, or this is what we are doing here, you can see that, or dp of I minus 1, we do k minus 1 and then we do j minus coin. Simple, right? This is how we can solve the problem. Now I hope you guys are clear with the tabulation approach as well. So let me show you the code. You can see that here is the code in Java, and I have written the code in C++ and Python as well. So this is something that we need to do, right? Now I hope you have understood the problem well and the solution also. So this is all about this problem. Again, one thing is there, that you can see that since I'm doing here I minus 1, right? So I need to start I with 1, and similarly I need to start j with 1, because this can using 0 can give me something error, right? Now I hope you have understood the problem. So this is all about the code. Now if you guys like the explanation, then you can hit the like button, and if you are new here, then you can subscribe the channel. Thank you.